Now it's time to see a complex application. So now in this tutorial, I will show you how to build and deploy a simple and not, but this is not the production ready, a multi-tier web application. A multi-tier web application using Kubernetes and Docker images. So this tutorial consists of two things, mainly PHP and a single instance redis to store guestbook entries. A redis database and PHP, a simple PHP front end. So these are the components. Let me write down. Let me check the sticky note. Yeah, here this is exercise 4 in this. That is PHP guest book and web stack. One is PHP front end and second one is redis single instance database, mainly single instance database, but we'll take some followers. That's it. And what is the objective? So here what we are gonna do is we will start up a redis leader, start up to redis followers, and third start up the guest book front end, and fourth expose and view the front end service, and fifth clean up. That's it. These are the objective. So these are the tasks that we are going to do in this. So before we begin the action, let's look into the PHP guestbook and COPS Kubernetes cluster architecture all put together. Here is that, the complete architecture. So let's begin with, as usual, let's begin with our creation of our cluster. So that has been done in our previous tutorial itself. If you did not watch that, kindly watch that tutorial, that hello cube tutorial. In that we have shown how to create our Kubernetes cluster using COPS with three instances. Basically this cluster consists of a master node, that's here, and a working node, that's here, and another working node, that is here. So total three machines. I will show that cluster also first. Yeah, let me go to the EC2 dashboard. Instances running. This is COPS machine through which I operate, and this is my cluster. These three are my cluster. You see the name Master US West 2A and Node US West 2A, Node US West 2B, and these are the three instances of AWS are part of my Kubernetes cluster. You see Master US West 2A master. This is master node, and these are two working nodes, and these two are part of my cluster, which are basically three instances in three EC2 instances in Amazon Web Services. I hope this is clear. So now how what we do, what all activities we do in this. So in this, we will begin with starting up a database. Starting up a database Redis deployment. So we have a Redis leader. You see that? We call this as a Redis leader. We will first deploy this pod. We are not creating pod alone. We are creating deployment object. When you do that deployment object, it will create a pod as well as a replica set. If you want, that also can be made. So first thing we are gonna do is we'll create the Redis deployment. Let me write that activities here on this side. Yeah, this is fine. So steps. Step one, we will create the Redis deployment object. Okay, we will write and create the Redis deployment. Then we have step two. So once this is done, so our Redis database pod, this is the pod. Inside that you have a container. So it's been deployed. So now what's next? The next thing is to create the Redis service. Create the Redis. We call this one as a leader. The first one we have created, that's a leader. Okay, Redis leader. Redis, we'll say that leader. Okay, Redis leader deployment. Then after that we will create a service for this. Create the Redis leader service. We'll write a service file, a service definition file, and we will create a Redis LSVC for this. Okay, then once that is done, then the third step is to create a deployment definition for Redis followers. This is Redis followers. What is Redis followers? I am going to explain, but for now it's two more additional pods we are going to deploy, and let me write that. And step 3, create, basically you can say setup, simply set up the Redis followers. You will do the same. Inside that we will do the same. One is deployment, pod is done, and in addition to that, service also. So create the Redis follower service, both. Okay. So then, so far, one Redis leader pod and a Redis service is done. And after that, we have created a Redis follower deployment. In Redis follower deployment, it's gonna bring two pods with one replica set. Basically, we use a replica set object. We'll mention two replicas, so then obviously we'll get the two pods. Okay. Then the next step is it's time for our front end deployment. So then we will deploy front end. We will create a front end deployment. When you create a front end deployment, we'll create two objects again. One is a pod object. So, and how many pods that will be created is again depends upon the replica set that we have mentioned. So we are mentioning 3, so we'll get the 3 pods of front end. So let me write that. Next, step 4, write and create front end deployment. So once it's done, it's time to write and create a front end service. And this here I will do both. One is cluster IP, second one is load balancer. So both I'm gonna do. Okay, so that's the 5th step. So fifth step is to create a front-end service for all three. Then this front-end service, I am gonna make it as a load balancer. So this load balancer, for this I will use Amazon Web Services. I will use the Amazon Elastic Load Balancing Service to do that. Then once I create Amazon Elastic Load Balancing Service from this cluster, I can able I will access I'm able to access this front end from the Amazon Web Services Elastic Load Balancing endpoint. Once you copy this Elastic Load Balancing endpoint and paste it into your browser, you should be able to access your front end. And obviously, this front end is connected to back end, so all together they have connected. So that's how the overall architecture looks like, with pods, with containers, with services, with deployments. Everything I have shown it to you visually, pictorially. I hope you really like it. So now let me attach those things also. So the step 6 is to get into the AWS ELB and copy the endpoint and paste it into the browser and access the front end of the application, front end of the guest book. Okay, let's do that. I hope architecture is pretty clear. Just look into the architecture. I will give you 10 to 15 seconds. Just look into the architecture. If you get any doubt, please rewatch the video. Rewatch the video and follow me in the coming forth section. Okay. Okay. I hope it's fine. It's fine. So let me get into the instance directly. This is our COPS machine. From here, normally I manage my cluster. So I call this as a COPS server, and I will manage my Kubernetes cluster from here. So let's do this and clear the screen. So this is a redis. We will begin the action. Let me get into the and here I am going to create make dir. This is PHP guestbook. PHP guestbook. Yeah. Now let me enter into that PHP guest. Okay, so now let's begin the action. As usual, let me show that sticky note. Our first step is to write and create a redis leader deployment. Okay, it's about the database. Let's write that. First definition file. So let's create the file. It's the name I'm gonna give is redis and ltep.ml. We'll keep it like this. We will create this file in our VS Code and we will copy that code from there and we'll paste it here. So this is my directory. So here I'm going to open my VS Code and here I'm going to create that file. So I'll say redis leader for that L and dep.ml. So let's begin. So kind deployment type. Okay, got it. Let me remove this which is not required. Rest all fine. Metadata, let's begin with the metadata. So here metadata name I'm gonna say redis and just L. That's it. That's the name of the deployment object. Then after that, labels, I'll directly attach a labels here in this. So labels, yeah, in labels I'll have the first label as a app and redis. Then I will have a role is leader. Then I'll have a tire. So this one I'll say backend. So then after that, I will directly go to the spec. Inside the spec, I will attach the replica set. This is a replicas object. So how many? I will go with only one. Okay. And after that, I have a selector. Inside that, I will go with the match labels. In the match labels, I want to match this with my labels. So I have this as a redis. I will write it as a redis. Done. So then I have template. So inside the template, I have metadata. Inside that metadata, I have labels. I will use the complete a similar label as it is. So I'll copy this and I'll paste it here from here to here. Okay. So let me bring it to the same level of indentation to this. Yeah, done. So then we have a spec. Here we need to mention about the containers. So I'm going to attach about the containers. So the name of the container I'm going to give is just a redis leader. That's not an issue. Redis L. That's the name of the container, or just leader, I'll say. Whichever is fine. Then image, it's dockered. So I'll say docker.io and then redis tag is 6.0.5. Okay, done. So let's keep the resources similar. Requests in resources, I'll put requests, not limits. This I'm going to change it to requests. I'll attach one more. It says requests. Yeah, got it. And inside the request, I will attach a CPU 100 mega. Then I will attach memory. This is 100 mi, capital Mi. You got it? Either way, that's fine. So now I'm gonna remove this limits. It's not required anymore. Yeah. So now let's come to the ports. Container port, I'm gonna go with 6379. Rest all fine. 6379. That's it. Absolutely fine. Let me cross check this quickly. Metadata is okay. Then spec is okay. Then template is fine. And spec, that's a container image, is also fine. And then resources we have provided. Container port is absolutely fine. Let me Control C to copy everything. Let's get into our server. Now we will create this file. Okay, let's do that. So nothing is there, but still. So Vim, let's create the file. It's redis L and dep and .ml. And let me paste it here, everything, and save and quick as possible. Save and quit. Done. So our file has been created, definition file has been created. Now it's time to create or apply this redis deployment definition file and create our deployment object. When we create our deployment object, replica set object will be created, as well as pod object will also be created. Let's see that. So for that, what I'm going to do is kubectl. I'll use apply and option F, and directly I will name it. So that's it. It's successfully created. It's been successfully created. Now let's check what all objects also has been created. But before we check, let's wait for some moment. Before we check all, let's only check the deployments. kubectl get deploy, because it will take some time to pod to come into the action. Okay, it will take some time for replica set to come into action. So that's the reason. Let's wait for few minutes, and before that, let's cross check the deployment. Okay, our redis cell, this is the name. This is the name I have given. So redis L deployment is ready. So one by one, it's up to date, available one. Just 30 seconds ago, it's been created. Now let's try to look into all other objects that were created when you create a deployment object. So for that, I'll say kubectl get all. That's it. So you could see that this is your, forget about this. This is a default service. You don't take this one. You don't consider this. We have created this a deployment object 58 seconds ago. At the same time, replica set object with the name redis L. This is the deployment name, and this is computer generated name is attached. The string has been attached to this, and then a replica set object has been created. One desired, we have mentioned only one. So one desired, one current, one ready. So I'm waiting for pod to be created. So I will give one more time all. Yes, this time pod is also up. You see that? Pod. So pod object, just 10 seconds ago, pod object has been created, and deployment object, and then replica set. So with creation of one object from deployment definition files, all three objects has been created. Okay. So now let's query the list of pods to verify that the redis pod is running. So kubectl get pod, and that's it. Redis L pod is up and running. I'll show you the picture also. So far what we have done is just this. We have created a redis leader, pod, and the container, and deployment and replica set objects. Okay, now let's get back to the, so the first step in this is done. Step 1, okay. Now step 2 is to create the, now step 2 is to create the redis leader service. Now its second step is to create the redis leader service. That's what now, you see that, to create a redis leader service. Let me do that. So again we have to write one more file this time. So the guestbook application needs to communicate to the redis to write its data. You need to apply a service to proxy the traffic to the redis pod. So that's why redis pod is pretty much important. A service defines a policy to access the pods. Then why do you require a service? Because we have two application, two separate services. One is front end, which is written on PHP. This is redis, which is a database. Now, until unless this front end communicates with the redis, you cannot store the data that has been typed into the front end. So that's the reason we have to make this communication possible between this front end pod and then a redis pod. For that, what we require, literally we require a service, because the service, the Kubernetes service object only can do communication possible. So that's what we are going to do. So let's get into that, and let's write a service object definition file. So the name I'm going to give is redis service svc.aml. Okay, before I give the name, let me create that in here and let me go there. So redis l and svc dot aml, and kind, it is service. Yes, got it. Yeah, so kind is service metadata. So the name metadata I'm gonna give is again similar, redis l for this. Yeah, spec. So labels, I will attach similar labels. I'll just copy paste it from here. So tip. So these three labels, I'll use the same labels. After the name, so I'll attach the labels section. So here I'll paste it. Okay, so let me bring other two to the same level of indentation of app. Okay, now it's fine. So labels is also given. Now it's time to attach the spec. So inside the spec, we will attach the port selector information first. So selector information, again you need to give the similar one, the same three. Okay, yeah, so let me bring it to the same indentation level. That's it, all fine. But only thing, okay, redis leader backend, redis leader backend, absolutely fine. Now it's time for the port and target port, because it's a service, and this is this one we are using is a node port. Okay, so 6379. So this is the port. And target port, whom should it target? Whom should this database target? This database should connect to the another container at target port. Okay, what's that target port? That is 6379. That's it, rest all fine. Let me save this file. Okay, I hope everything else is fine, no issue. Ports spec, yeah, I hope it's fine. Let me save. Okay, so it's a wrong one. Yeah, sorry. Okay, let me create a file here, vim, and it is redis l and svc.aml, and insert mode, paste it, wq, save and quit. And it's time to create a first service for the database, redis database. So what I'm going to say, same command, kubectl apply option f, and then it is redis l svc. That's it, your service has been created. Let's query the list of services to verify that the redis service is running or not. So what I'm going to do is kubectl get svc, and here it is, redis l. That's what the name we have given, if you remember. And it is a cluster ip type service, and then it's up and running. The target port is 6379. So whatever is running at this port, that it will connect with that port. Okay, so our service has been created. So with this we have reached to this level. Okay, and we have completed the second step also. So what's next? Next is to create a Redis follower pod, or literally a Redis follower deployment, and then a Redis follower service. That's the next step. So let's get into the action again. So now let's set up the Redis followers. Although the Redis leader is a single pod, you can make it highly available and meet traffic demands by adding a few Redis followers or replicas. Now you got it why I am creating this Redis followers, though I have a Redis leader. So I want to meet the traffic demands. If traffic is too much, automatically these Redis followers takes up the load and it supports our application. So that is the power of Kubernetes. So the future is all lies with the Kubernetes. Okay, so now let's do that. Let's create our Redis follower deployment file. So for that, I'll go to this and I'll write as Redis follower f and deployment dep.ml and click OK. So kind again, it's a deployment. And let me remove that kind, and then yeah, deployment is absolutely fine. Then metadata name immediately have to change. This time I'm gonna give redis hyphen f and spec. So literally it's better to copy this, it would be much easier. Redis l dep. Okay, let's edit here only, it would be much easier. Okay, f, then labels will keep it same, follower backend and spec, but the replica I want two. The replica set object I want two. So that's what I said to. And selector match labels, app redis, and a remaining template follower backend, all fine. Now let's directly come to the spec, the container section. So in container section, the name I'm going to give as a follower, the container name is follower, and then image name I'll get it from somewhere else, not this one. I will use a different name who acts as a follower to that. Okay, so what I'll say is GCR, and then IO, it's a Google container registry. From there I'm going to get that. So Google underscore samples and GB redis, redis, and this is the name follower and version 2 tag. Okay, so let me cross check it. gcr.io Google samples GB redis follower tag 2, all fine. So resources will keep it same, requests everything fine. Port, container port is 6379. So this is what 6379. This is what it has to target. So let me copy everything and create vim. It's redis f and it's dep.ml and paste it everything. WQ save and quit, and it's time to apply the redis deployment definition file using apply the redis deployment using the following redis fdep.fml .ml file. So kubectl apply option F, and it is redis f dep.ml. So let me execute that. Yes, you could see that deployment.apps, the redis f also been created. Now let's look into the deployments. Clear the screen, and what I'm going to say, kubectl get deploy. Yep. Yeah, so you see that? You see that? Redis F and 2 by 2, basically it's gonna bring two ports. That's the reason it's saying 2 and up to date are 2 and available are 2 and that just 23 seconds ago. So what I'm gonna do is I'm gonna fetch all, because this deployment is going to bring one replica set object and one and two pods objects and one deployment. So that's why I'm gonna say kubectl get all, and you see, yes, here is that. You got that pod redis L. This is world one 14 minutes, and pod redis F2. Two pods has been created because that's what the replicas number we have mentioned, and the pods has been created, the pod object has been created. Then you see this is redis F deployment object has been created, and here you see replica set 222 all 222 has been also created just 59 seconds ago. So all done, all set. So let me mark this. So second step, follower step is also done. Then it's time to go for the fourth step. What's that? The fourth step is oh, this is our front end. It's time to, okay, but before that we need to create the redis service, redis follower service. Let's do that. Let's quickly do that. So this is done. Now let me say redis follower service. So the guestbook application needs to communicate with the redis followers to read data. To make the redis follower to discoverable, you must set up another service. This time I'm gonna say redis f and svc.ml, and by and large I will use the same one. I'll copy paste this service redis. Yeah, so with version service and then here I'll say redis F, and then labels are fine, selector are fine, target port spec ports 6379 is fine, but one more thing we want to attach here is after the port you remove the target port. After the ports I'll attach selector. Okay, selector is already there, no? Yeah, okay, it's done, all done. There's nothing much to add. Ports is 637 and this is a backend one. So rest all fine. Let me copy this quickly. And here I'll say same vim redis f and this is svc.ml. Paste it. Save and quit. And run. And now it's time to create our redis follower service object. So kubectl apply option F and file name redis follower and svc.ml, and here is the redis F is created. Okay, now let me check the services. kubectl get svc, and you should see redis F service as well as redis L service. Redis L service 9 minutes ago it was created. Redis F service just 13 seconds ago. So that's it. I think in this picture all set till now. So now let's move to the fourth step. So the next step is to set up and expose the guestbook front end. This is what front end pods with the front end containers. So now that you have the Redis storage of your guest book, that's up and running. We have our guest book storage, redis storage, these databases which are up and running. Now it's time to start the guest book web servers. These are the one guest book web servers, these three pods. Like the redis followers, the front end is deployed using a Kubernetes deployment, because when you use a deployment you can also bring up other objects like pod replica set. The guestbook app uses a PHP front end. It is configured to communicate with either the redis follower or leader services, depending on whether the request is a read or a write. The front end exposes a JSON interface and serves a jQuery Ajax based UX, user experience. Okay, let's create our let's create the guestbook front end deployment definition file. What I'm gonna say is front end dep, that's more than enough, .ml. So we will take the similar one. I think we'll copy from here only existing ones. Yeah, paste it, and now let's customize this to our front end. Let's begin. It's apps v1 deployment is absolutely fine. The name I'm gonna give is just front end. That's it. Front end. That's the name of our guestbook front end deployment. Then we have metadata, and after that labels are not required in this section, so let's leave it like this. I'm gonna remove. Let's move on to the spec directly. Spec, I want to have a 3. Yes or no? Let me check. Yeah, 3 pods. I want 3 pods. Yeah, so I'll change it to 3 pods. Then selectors. So here a name is front end. So match labels, I'll go with the guest book. Here the name is guest book inside the match labels. I'll say guest book. Then tire, it's front end. Then template, metadata, labels, I'll keep the same one. This is guest book, and this part is not required. I will remove that. Tire is front end, not back end. Yeah, and then we'll move to the specs. So inside the spec, so by the time it's not required, this part, labels and metadata, this part is more than enough. Yeah, let me come to the containers section. In containers, the name I'm gonna give to this container is, this is PHP based and redis backend. So that's the reason PHP redis. And image, so GCR, I'll copy this directly from I think it's F. This is not F, this is F. And from here I'm gonna copy this image, so we will just modify it. Front end, yeah, paste it. gcr.io google samples gb, and google samples is fine. Then gb, here I'm gonna say front end. This is guest book and front end version 5 tag. This is tag 5, and I want to attach some environment variables here. So env name is get hosts from, that's the environment variable, that's the key, environment variable key. And after that I'm gonna attach the value, that is value is DNS. And remaining resources, request CPU, memory, fine. Port container, this is 80. This is 80. That's it. So let's save this and Control A plus and Control C. So everything been copied. then into the server, copy server, then clear the screen, say vim, and name is front and dep.ml, and insert, paste the ML definition file script, then say wq save and quit. Now run it. Let's create the front end deployment object. So kubectl option F, apply option F, and front end dot app. That's it. Deployment dot apps front end is created. Let me check the front end. Let's query the list of deployments that are available first. So kubectl get deployee, and here it is. Front end 3 by 3, because that's the replica set. We have mentioned 3 pods, up to date 3 available just 17 seconds ago. So what I'm gonna do here is I'm gonna try to fetch everything. kubectl get all, whether all objects has been created or not. As absolutely, you see that 3 pod objects, and this is our deployment object, and this is our replica set object. You see that these are 3, current 3, ready 3, and age 39 seconds just. So it's been created successfully. So now our all 3 objects, you can see that if you want to fetch only 3 objects specifically, only 3 pods, we can say 3 pods. Okay, and here is that our front end pods, 3 front end pods. I'll show you that. Total how many pods we have? You see that total 6 pods. I'll show the diagram here. 6 pods. We do not know exactly which pod in which instance, okay, in which working node. That we are not sure. But still we have 6 pods, 2 redis F and 1 redis L, and 3 front end pods. Okay, that's it. We'll mark this, write and create front end deployment. Then our next step is to create a front end service. Okay, front end service. Let's do that. Now it's time to create a front end service. The Redis services you applied, is only accessible within Kubernetes cluster, because the default type of service is cluster type. A cluster IP type service provides a single IP address for the set of pods the service is pointing to. This IP address is accessible only within the cluster, within this cluster. But we want this to be exposed to the external outside network also. For that, what we need to do? If we want guests to be able to access your guest book, you must configure the front end service to be externally visible, so a client can request the service from outside the Kubernetes cluster. However, a Kubernetes user can use kubectl port forward to access the service even though it uses a cluster IP. Let's do that. So let's create our service. Front end service. So the name I'm gonna give is front end svc.ml. So what I'm gonna do is simply I will use the existing svc code. I'll just copy it and paste it in front end svc.ml file. So let's begin. The name is kindly service metadata. Here I'll say front end. Then labels should be changed. This is guest book, and this is not required at all. This is front end and spec. So in spec, we'll keep the selector. We'll copy these two things exactly. So I don't need to type it again. So let me paste it here. Yeah, fine. So now port, I'm gonna go with 80. Yes, port is fine. Selector is fine. Okay, that's absolutely fine, because we will save this and we will run it. See. So let me get into our instance. Here I'll create one more file, vim. This is front end svc dot ml, and insert mode, paste it, wq, save, clear the screen, and let's create the service. Let's create the front end service. kubectl, apply, option F, and the name is front end svc.ml, and your service front end has been created. Now let me see, kubectl get svc, here it is, front end. But the problem here is this is a cluster IP, because we have not mentioned any specific type here. We did not mention any specific type. If you don't mention any specific type, by default the service will be of cluster IP type. You see that, the cluster IP type. Now how can you access if it is a cluster IP type? The only option that you have is viewing the front end service via kubectl port forward. So we have to run kubectl, then we have to say port forward, port forward, and then service name is front end, correct? And you could see that front end only, front end. Then how do you want to forward it? 8080 of the port. Let me cross check that whether it is 8080. Let me get into the front end, the deployment. Yeah, it's 8E. So now we want 8080. This, what if you get a call to the 8080, it should be forwarded to port 80, and at port 80 you have a front end pod. Inside that front end pod you'll find a front end container. That's what the magic here. Okay, but yeah, let me execute it and see. Yes, the response is this, forwarding from, this is a local host IP 8080 to this, and forwarding from this IP to 8080 this, and we can able to access it using local host IP. Okay, that's it. It's absolutely fine, no problem. But to view this, we can, if you from localhost we can view it, but this is not the production ready case, because using cluster IP you cannot do that. So that's why what I'm going to do is I'm going to do Control C. I'll come out of this, I'll clear the screen, and kubectl get svc. You see that? So now this is not production ready. In this way we can't do. So what is required? Here we require a load balancer type service. So if you deployed the front end svc.ml definition file with type load balancer, we can find IP address and we can view our guest book through our browser, or we can give that IP address to anybody. Anybody can view our guest book application through their browsers, through internet. So for that, what I'm going to do is I will get into the SVC file and I will attach a type, and type, that is what type it is? It is load balancer. That's it. You see that? It's done. Now I'll copy this. So now let me do ls. You see that these many files we have, total 6 files we have created. 6 definition files we have created so far, out of which I need to change this front end svc.ml. So for that, what I'm gonna do is I'll say vim frontend svc.ml, and I'll say percentage d. So all gone. Now in insert mode, and let me paste it. Okay, this is a wrong one, sorry. Yeah, again I'll say percentage d, everything should be gone. Now let me copy this properly from here and I'll paste it there in spite of editing. Yeah, you see that now this time load balancer, rest all same, but the only thing we have attached is a load balancer. So now let's apply the front end service from this and we'll see. kubectl apply option F frontend svc.ml, and the existing service has been configured. That means it has done enough changes to the existing service, configured existing service. Now let's check what had happened to the existing service. So kubectl get svc, and here is that this time the service is of load balancer type. You see that it's a load balancer type. But to access this load balancer and our front end application, we need to have this external IP. See, this is external port is mapping with the 30,064, which is the internal. So let me get into this diagram so that it will be clear. Still that it's done. Now we have created front end SVC with load balancer. Yes. So far this is what we have done. So now our load balancer is spinning. This is a AWS. Now this load balancer port is 80, is mapped with the front end of this front end pod 30,064. Okay. Now this is still pending. So what I'm going to do is I will get into our AWS Amazon Web Services and I will check the status of the load balancer, whether it's been created or not. So Amazon, come. So this one, okay, let me close this. It's not required. Detail, close this. I am close this. No, cancel it. Okay, here I have. So let me click on load balancer here. Where is that? Load balancer network. Yeah, load balancing. So click on, open it on new tab, and here we should see, yes, that's it. You see that? Our load balancer just now, at this moment it's been created just now. You see that? And let's check the health condition of this load balancer. Let me click on this. Yeah, now we will enter into the load balancer. Let's check the health condition. So all fine, availability zones and status. This is very important. Health checkup. So 0 of 0 instances in service. So at this moment, no instance has been started. Let me look into the instances. So see, there are no instances, but you can see the availability zones. US West 2B, US West 2A. This is where our instances, our nodes, working nodes are present, and that's where our load balancer also being presented, being created. Now we should get two instances created. Let's wait for that. So it has done the health checkup, all fine. And listeners, So TCP load balancer port is 80, and at this port it is listening to instance port 30,064. Then here you can check the monitoring, and this is stats. You can see that complete information, the Kubernetes cluster, that is ours, kubewipro.imlac.com, and then Kubernetes service name, the service which is connected with this load balancer, that is front end. You see that front end, this is default is a namespace. Okay, namespace, and this is front end. Okay, if you want to see what is that, I'll show you that also. Okay, I'm gonna say kubectl get ns. You see that this is what the default namespace. You see, default namespace. Inside this default namespace, only all these services, pods, everything has been registered. So that's how it has shown. And this is one. Okay, let's cross check this. Still, that's fine. So 80 is forwarding to 30,064, and this is our security group. These are some of the attributes about that load balancer, but I will refresh it and see what's the status. Yes, two instances in service. Fantastic. And here you see that instance ID. So two instances were properly connected in service. What are those instances? These are two instances are nothing but our working nodes. You see that name, at least you see the name. Okay, to be, and you see US bus 2A to be, or if you have that tout for B85B D463. B85B D463. That's it. What a load balancer has done so far is it has established a connection with our working nodes. That's it. It has established a connection with our working node. Now both the working nodes are in service. Okay. Now let me show you that. So with this, our load balancer is successfully running. So now it's time to get the AWS elastic load balancing endpoint. For that, let me get back. So I'm gonna say kubectl get svc, but let me clear the screen before that. So kubectl get svc, and now you see front end, this is our load balancer, and external IP, we got it. With this external IP, and with port 80 we should be able to access our application. So you can copy it either from here, or you can copy it from other part. Okay, you can copy it from anywhere. That's all up to you. Where do you want to get it? So what I'm gonna do is I will fetch it from AWS only. So here you have two options. Either you come here and just copy the DNS name from here, or else simply get to the load balancer console, a dashboard, and here you should see the direct copy option. Copy it. And the port mapping is 80. So I'm gonna paste it here, and the port is 80, and say enter. Magic happened. Here is your app. Here is your app. You see that? This is our guest book. So who's the guest today? Today's guest is Daksha. So let me submit it. And it's been submitted. And one more. So clear? So that's how we access, we use a multi-container. You see that? This is our AWS endpoint. We have done it. Now let me mark everything. We have validated it. We have visited that app also. So now it's time to clean up. But before that, what I'm gonna do is, as part of our like overall project, we just want to scale this web front end. So we have only 3 pods. I just want to scale the web front end. We can scale up or scale down as needed because our servers are defined as a service that uses a deployment controller. So we will run kubectl scale, then deployment front end, and deployment front end depth, and option replicas. Directly you can use a replicas option. Replicas equal to 5. Okay, front end depth is not there. That's fine. Let me check it. So kubectl get deploy. Yeah, it's front end. It's just front end. Sorry. That's my mistake. Yeah. Okay. Deployment.apps front end is scaled. So now let me fetch the pods. So kubectl get pod. You see that? Just 2 were existing 20 minutes, 3 were existing 20 minutes, 20 minutes, but 2 were added 13 seconds and 13 seconds. So that means to these 3 pods, 2 more pods were added into the working nodes, node 1 and node 2. Let me get back to this. So that's how you can easily scale up your pods without any difficulty. So that's the power of Kubernetes. I think as we work more, we will feel and we will experience the power, the ultimate power of Kubernetes or Kubernetes. So now we can also basically scale down. We can also scale down this by running kubectl scale, and again similar deployment, and it's front end, and this time again replicas. This time I'm gonna make it 2. Now you see that again the front end has been scaled. Let me say kubectl get pods gone, gone, gone. 22 minutes and 86 seconds. That's it. Remaining 3 were gone. So let me make it normal. I want to run it 3 pods, not 1. So I will make it back to the normal. And then now let's see. So this is how I want to run. That's it. So all 3 are up and running. So now it's time to clean up. So all done. It's time to clean up. Step 7 is clean up. So deleting the deployments and services also deletes running pods. That's it. If you delete a deployment, it will delete running pods and it will delete a replica set also. So let's use their names to delete the multiple resources with one command, or we can either use um, labels or names, but we will use this term a label. Okay, not names. kubectl delete deployment and option L, it's app. Option L says it's a label, and label we have gave is app equals to redis. Okay, deleted. All front end one are deleted, and now this time I'm gonna say kubectl delete service, and same. So redis F and L, both the services has been deleted. Now kubectl delete deployment, but this is front end, so I'm gonna mention not label. I'll just delete as a normal one. Okay, deployment. Yeah, deployment front end directly. Front end gone. Similarly, service front end. I think service also we gave the front end name. It's all fine. Delete service front end. That's it. So now let's cross check whether we have left anything. All should be deleted by now. If not, we have to delete that also. So that's the reason I would say now kubectl get all. Okay. Oh, service is still there. I think it will take few more seconds to get closed. Before that, I will cross check others. Uh, kubectl get pods. I think it's gone. Get pod gone. kubectl get svc. Other than default one, all gone. kubectl deploy gone empty. Then kubectl all. Let's see all. That's it. Everything is gone other than the default ones and then the job that I have created few days before. Rest all is gone, completely wiped off. It's clean. Hence, cleanup is also done. So we have successfully finished this application. But let me close this with this. Getting back to our website and let me refresh it. It should be gone. Yes, it's gone. That means absolutely successful. Let me meet you in another example.